Okay, so just wanted to, well, we're looking at the equation for aerobic respiration, but we're just trying to understand what balancing equations mean. We've started trying to balance them, um, and well, let's just restart again, otherwise it won't make complete sense yet. So we start off with an unbalanced equation here. This equation is not completely false because what it does tell us is that glucose reacts with oxygen to produce carbon dioxide and water, and it gives you the formula of each of those substances. Um, but what isn't true is that it seems to be suggesting that one molecule of glucose, which I've drawn down here, reacts with one molecule of oxygen, which is here, to produce one molecule of carbon dioxide here and one molecule of water. Now that can't be right because if you add up all the atoms of the individual elements on the left, they don't match up to the ones on the right. So what we can't do when we're balancing equations is change these numbers. So I can't, for example, balance the carbons by just writing a 6 there, okay? Because if I did, I'm no longer saying that carbon dioxide is produced. That is no longer carbon dioxide. It's some compound which I don't think can even exist. So we can't do that. What we can do is multiply the amount of molecules that there are in total. So I could add another molecule like that if I like. And if I did do that, then that would mean I'd demonstrate that by putting a 2 up there. Okay. So, so we clearly have more than one molecule of glucose in this reaction, more than one molecule of oxygen and carbon dioxide and water. We have millions of all these different molecules, and what we're trying to do when we balance an equation is say is kind of give the ratio of the number of molecules that react with other molecules and so on. So, for example, you could say for every at the moment it seems to be suggesting for every one molecule of glucose react with one molecule of this to produce one molecule of that, one molecule of that. So the ratio would be 1 to 1 to 1 to 1. That clearly can't be the case because of the number of atoms. We can also demonstrate this in a table down here. We've started editing this, so that's wrong now, but I'll just erase them all so we can just do it all together. What we're doing, so the R stands for reactants, the stuff on the left-hand side, the stuff that was there before the reaction, and the P stands for products, the stuff that is there after the reaction that get produced. The reactions react, the products get produced. So how many carbon atoms are on the left-hand side? We can see that there are 6, and you can work out from here that there are 6. We need to be familiar with how to understand all this without the diagrams, of course, because you won't get the diagrams, but the diagrams are helpful for us understanding it now. So we've got 6 carbons, and on the right-hand side we've only got 1. Oxygens, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 on the left, and 3 on the right. Hydrogens we have, each carbon has got 1 hydrogen and then an oxygen and hydrogen. So each carbon's got 2 in total. Well, it says up here anyway, 12. Okay, and then on the right-hand side we have 2. Definitely not balanced. So what do? Well, the trick to balancing equations is to try to balance one substance at a time, one element at a time. That's one of the tricks anyway. And then sort of reassess, look at how everything is after that. So maybe we want to start off by balancing the carbons. The way we would do that is by producing more of these carbon dioxide molecules. Now we can also, one thing we can say for certain is that this number here will be 6 times this number, because all of the carbon atoms in the reactants are within this molecule, and all of the carbon atoms within the products are within this molecule. So these carbon atoms must go to this molecule here. And so it could be 1 to 6, or it could be 2 to 12. But let's start off with 1 to 6. So if that's 2, that makes it 3. Now we'll just double all of that. And I think I should have made these molecules a bit smaller, but probably get away with it. Okay, so that means I can now say that's 6, and I can update the table to say that we've got 6 carbons now. So the carbons are balanced, but when I did that, obviously I changed the number of oxygens. So now the oxygens are 12, but also this one, so 13. So I can just add a 1 actually. Let's do that. Yeah, that's right, isn't it? So 6. So this number shows you the total number of the molecules, not the number of carbons. So some people think that this is 6 carbons and 2 oxygens. It's not. As you can see, 6 carbon dioxide molecules. Okay, all right. Next thing I probably would suggest to do, it would be the most obvious looking, is to balance the hydrogens. The one trick as well is that to balance the elements that are in one place on the left and one place on the right, if you can do that, the oxygens are spread amongst, every single molecule has oxygen in it. So what I'd suggest to do is balance the other elements and then use this handy little molecule afterwards to top up the oxygens on the left if we need to. So on the left we've got 12 hydrogens, we've only got 2 on the right. So what are we going to do? We're going to multiply this by 6 as well. Okay, so that's 3, and then we're going to just double all that. Okay, so we've now got 12 hydrogens. So the carbons are balanced, the hydrogens are balanced. We've clearly changed the number of oxygens now. We have 12 there, and then we have, so that adds up, so 12, 13, 14, 15, 16, 17, 18. So that makes a total of 18 oxygens on the right hand side. Okay, we're basically there now. The last step is easy if you think about it, because we just need everything. If we look, the carbons are balanced, the hydrogens are balanced. We only need to balance the oxygens. We need to add more oxygens on the left hand side, which means we just need to add a few more of these oxygen molecules. I just need to also update the formula, so that's now a 6. So we need, how many more oxygen molecules do we need? We need 10 more, so we're going to add 5 more oxygen molecules. Each molecule has got 2. So we're going to have a total of 6 oxygen molecules. Okay, so that means we've got 12 plus 6 there, so 18. Okay, and now that is balanced. You can just double check it by adding them all up, and we need to, I need to write a 6 there. So that's a balanced equation for aerobic respiration. Now you can play around with balancing equations in a similar way to what I've just done there, using this thing from the website PHET, which is developed from the University of Colorado. And I'll show you now. So yeah, so what have we got here? We've got phosphorus chloride reacts, is the reactant. I guess it decomposes to produce, oh okay, this is going to be, I guess, phosphorus pentachloride, and this is phosphorus trichloride, and chlorine. So we have to just add a 1. As we know, as you just saw a moment ago, I didn't put a 1 there. Let's just briefly look back at that. You don't put a 1. If there's no 1, you presume, if there's no number, you presume it's a 1. So in this case, I mean, yeah, you put a 1 there anyway. So you start off by putting a 1. It's a 3D molecule, so it makes it a little bit harder to count the atoms, but you can, so you maybe just be able to work out 1, 2, 3, 4, and you can see 1 behind, 5. So the chlorine must be in green in this diagram, and phosphorus is the single atom in the middle. So you can see that we've got, on the left-hand side, we've got 1 phosphorus atom. On the right-hand side, we've got 1 phosphorus atom. On the left-hand side, we've got 5 chlorine atoms. On the right-hand side, we've got 1, 2, 3, 4, 5. So actually, it looks like this is already balanced. So if you think it's already balanced, you click check, and it says it's balanced. You get 2 points if you get it right first time, 1 point if you get it. You can actually get, I think you also get 1 point if you balance it, but it's not simplified. So I'll see if I can give you another example of this, where it's not simplified. So we've got 2 nitrogens on the right hand side, so I'm going to put 2 on this side, but now we've got, so that would make it 6 hydrogens. So if I did that, that would be 6 hydrogens. Now, so we've got 2, 1, 3. If I did 4, 2, 6, that is still balanced, because now on the left hand side we've got 4 nitrogens, on the right hand side we've got 4 nitrogens, on the left hand side we've got 12 hydrogens, on the right hand side we've got 12 hydrogens, but I only get 1 mark because I didn't simplify it. Okay, so it's quite a good game to show you how to balance equations. Anyway, I'll stop there. Okay, oh no, I'm going to stop there. Let's try that again.